Welcome to Harnessing AI and Automation to Supercharge Your Data Engineering Team. We're so grateful you're here. We know this is a hot topic for so many teams who are burdened by the amount of work that they have to do. They don't have the capacity to meet demands by the business. And we know that AI and automation can really do wonders for improving productivity. And so we are here to give you some of those insights into how you can implement those projects and do that successfully so your team can get back more time. With that, I would love to introduce today's speaker. Today's speaker is Sean Knapp. Sean is the founder and CEO of Ascend.io. He started his career at Google, where he was the tech lead for Google's legendary web search front-end engineering team, before co-founding Ooyala, where he was CTO and chief product officer, overseeing product, engineering, and solutions. As the founder and CEO of Ascend, Sean has been working to build adoption of AI on our internal team, and he's been working hands-on building our new AI agent Otto. He's learned firsthand how to build and implement AI and automation projects, and he's really excited to share his insights from our journey into AI over the past year. So without any further ado, welcome Sean Knapp. Thanks for being here.
Thanks, Jenny, for the intro. And I think one of the funny parts I was thinking of right as Jenny introduced me was, it's kind of a shame. I actually shaved this morning. I know it doesn't look like it, but I shaved, and I noticed that as I was shaving, I actually took off quite a few of the gray hairs, which, as Jenny, as you were doing the intro, reminded me that was 20 years ago when I started back at Google. And it was a pretty exciting time as we were even back then creating really large data pipelines on top of Google's internal Hadoop infrastructure at that point in time. And one of the, I think, the really amazing things that's happened over the last 20 years is we've continued to invest in not just bigger, better underlying technologies that can store and process more data, but we've also had some really tremendous advancements in the technology that helps us as engineers and our teams as teams of engineers really be far more effective at what they do. And one of the things that I get really excited about is the fact that today, one or two data engineers or analytics engineers really can do what it used to take 5, 10, even more data engineers before to achieve and accomplish. And that's one of the core topics for today is how do we actually help our teams make this transition, take advantage of these really incredible new technologies and capabilities and methodologies to get more and achieve more? And put another way, how do we actually help teach them some new really cool superpowers? And so against that backdrop, I'd like to just give a little preview of the core agenda here. Part of what I want to start at is talking through the current state of data engineering. Where is the overall alignment around use of AI and automation? And then actually want to introduce 4 key frameworks. We're going to touch on them, I'd say, at a fairly high level, and I'll try and get them to go deeper and deeper. But obviously, we're going to, with 4 frameworks, it's going to be hard to touch on all of those in great depth. If you do have questions, please definitely toss those in the chat or in the Q&A, and we'll try and get to it at the tail end. And then also want to show what that looks like when we bring it all together and what we've been able to achieve inside of the Ascend platform as well. So let's talk through the current state of data engineering. And it is very much a scaling challenge. And as I think over the last 20 years of my career, we've always talked about scaling being the number one thing. In fact, I think I actually still have my Big Data is a Cluster t-shirt, which we created back in the early days of Ascend. And it was really fun to talk about how much of a mess and how much chaos this big data world can be. But one of the things that we've really started to observe is the scaling challenge itself has changed dramatically. It is no longer a matter of, can I scale to store enough bits and bytes or process enough records? Companies like Snowflake, Databricks, Amazon, Google have all done an incredible job of taking those challenges off the table. In fact, as part of one of our annual surveys, even a couple of years ago, the vast majority of teams said that storing and processing large volumes of data was no longer a real concern for them. The scaling challenge that does emerge now is really this challenge around team productivity. We now have access to all these amazing underlying technologies and these incredible superpowers, but how fast we can go and build new products is still something that's pretty tricky. just earlier today, I was on a call with a CTO, and I've had a number of, actually on a weekly basis, have a number of calls with other CTOs, CDOs, and CEOs. And there's always this classic thing of, gosh, like we have these amazing people, they're in our data team, they're really smart and they're working really hard, but we have all these things we want to go do and achieve, and we're not getting there yet. And it seems like things that should be pretty simple and straightforward still take a lot of time and energy. So as teams really grapple with this and figure out how do we solve for those challenges, it's tricky. And I think it's important for organizations to truly embrace the fact that, look, the vast majority of your teams are at or over capacity. Demand for what they're doing is increasing, and in most cases is increasing faster than the capacity of the team is growing from a headcount perspective. And the reason why that matters so much is we do have to take a bit of a step back and think much harder around, look, if we can't just throw more bodies at these problems, how do we get creative and help our teams achieve more and pull them out of the muck and out of the redundant and repetitive tasks? And how do we get them into doing more advanced things? So one of the challenges that I often like to ask data teams is, what kind of data engineering are you truly doing? I would contend most people would love to do the thing on the left, and we think, we're sort of the Tom Cruise in Minority Report doing really advanced, fancy things, and we probably are for 5-10% of our job. But oftentimes, most of what data engineering is still feels pretty primitive and pretty basically like plumbing or connecting all these various data pipelines. And it feels a lot more like the stuff on the right. And that's where I think the real goal is. How do we get ourselves out of that realm and into what I'd consider to be the much higher capacity and higher leverage parts of data engineering itself? So to get there, let's talk a little bit more about the future of data engineering, especially as I see the role AI and automation plays there. And even more, let's talk a little bit about, are people ready for this yet? Because we can talk all about this really fancy, exciting future where AI and automation is going to do all these amazing things. But if people don't want it, we're going to naturally get organizational resistance, and it won't really prove out to be as anywhere near as successful in any individual company strategy as you would really want it to be. So one of the things that we do is, as part of our annual survey, we do ask individuals a whole variety of different questions. But one of the categories of questions was, how do you expect Gen AI to impact your day-to-day data practice? And what became really interesting was the category of things that we see people really wrapping their heads around that they would like to see Gen AI be able to do. And this tends to fit in a lot of the category that we see of things that we need to do as part of data teams, but oftentimes don't even have the capacity or the time to achieve those things. I think this is, I'll circle back to in a little bit later, but I think that's one of the really interesting categories when we think about where do people want to use Gen AI as data teams. It comes in this testing, code generation, documentation. This is one of the areas we're seeing really fast adoption. And I think it becomes a gateway to doing much more powerful and interesting things with Gen AI. The second category that we look at is automation. Automation is oftentimes what I call the little sibling to AI. AI gets obviously a lot of attention right now, but there's also a lot of things we do as data teams that benefit greatly from higher levels of automation. And the reality is most organizations still are grossly underinvested in automation itself. And as part of our same survey, when we asked teams, do you have automation? And if you don't have automation, do you plan on investing in it in the next 12 months? We were actually shocked to find that less than 10% of organizations surveyed believe they truly have automation in place today. Yet the overwhelming majority, over 80%, plan on implementing automation strategies in the next 12 months. And so I think this is a second really great signal for us as far as the overall readiness of organizations to adopt both AI and higher levels of automation to get their teams more leverage. All right. So now that we've identified that the teams and organizations are quite ready for AI and automation investments, let's work through a couple of frameworks here, to be specific, around how do we systematically work our way towards greater adoption? How do we do it in a way where we build trust? And how do we do it in a way where it's safe? And these frameworks are by no means I would consider proprietary to Ascend. These frameworks are honestly just byproducts of large numbers of conversations that I have with a lot of other data executives and how their teams and how their organizations are thinking about AI and automation. And so the first framework that I like to spend time on here is just levels of access. And I think this has to be that first framework to really align organizations around is how much access to our data do we give these things? And you may have different levels of trust for automation versus AI, for example, but it's a pretty simple framework. And it generally starts with just really basic data. For example, do you just give AI access to general knowledge, chat conversations, some basic Q&A, or do you go to a higher level? For example, giving it access to non-public knowledge, things that might be a little bit more domain specific to your business or to specific roles. The next layer after that, oftentimes, especially in the data engineering realm, becomes access to code, to logic, your Python notebooks, your data pipeline code, your actual logic and core definition, the sort of proprietary secret sauce that makes your systems do what they do well. Fourth one after that generally becomes more operational data, not just the code, but the byproduct of the code itself. How did the code perform? What was the metadata generated by that? And then lastly, generally the fifth highest level of access becomes data. And that even gets broken down into different subcategories around summarized, anonymized, or even the raw data, which tends to be the most sensitive. And I'm not going to spend time really double clicking into here because I actually think that's where most of the conversation around data access has happened today. But the purpose of a framework like this is to also highlight before you even get to the point of giving AI access to your raw or even summarized data, there's a whole other set of content you can give it access to where it can perform really compelling and powerful things that gets pretty exciting as well. And so we'll dive into that. All right, so second framework that I want to highlight is that of user trust. You may have, as an organization, even said, you know what, we as the organization trust that AI and automation are going to do these amazing things, and we think they're all going to behave perfectly, and we're willing to give it access to everything. Probably not yet, but hypothetically speaking, we're going to give it access to everything. You still have another challenge, which is, are users going to actually use it? And the reason why I think this matters is you can give the most powerful, compelling capabilities in the world out to AI, but if your actual team doesn't want to use it, it's not going to really move the needle for you. So let's talk first around some of these tiers. We already see all of our teams adopting these. I have to imagine, certainly based on my conversations, the overwhelming majority of data teams that we work with are either using GitHub Copilot in VS Code or their other editors like IntelliJ. Maybe they're using Devin. Almost all are using ChatGPT. And so we're already finding that the sort of baseline productivity levels of using Gen AI are already there. Users are trusting it, but it's an important place because the user's still very much in the driver's seat and getting information, then making decision on that information. Where we're starting to see the next layer, and I think this gets really interesting, is larger task offload. Not just where the user's in the driver's seat, but to actually say, you know what, AI, I would love it if you can just go and document this for me, or go test this code for me and let me know what happens. The reason why this is the next threshold is it is absolutely embracing a higher level of trust by the user for the AI system itself, but it's still in more of an offline capacity where it can operate. It's still a higher degree of trust, and the blast radius, if a mistake does happen, will be more contained than in some of the higher levels. I do believe it's important to systematically work our way up through these trust tiers. Trying to jump somebody all the way to the very end can be pretty scary. And so let's talk about what happens even after this one. The next layer I like to brand as the virtual promotion. And I do believe this becomes one of the harder thresholds for us to cross over. And I also think it's one where we're just on the fringe of both the underlying models being advanced enough to be able to pull this off, as well as the frameworks and the implementations on top of those being sophisticated enough to actually do a good job with these kinds of tasks. And I'll dive into the tasks later. But when we think about a virtual promotion, that is a how do we get our data teams out of being plumbers and into architects? How do we get them out of the weeds of writing so much code and thinking more of you have a team of junior developers at your direction, pull together the pieces and architect and design more? And I think this becomes a pretty important transition period because in many ways, does require a mindset change for developers as well. Oftentimes, over the course of our careers, it happened over the course of years, sometimes even decades, that people move from a purely hands-on coding role into a much more architect advising style role. And we're going to see a really interesting shift from developers and that ability to move along this path very quickly. And I think that's where we'll see some will be able to adopt it fast, some will take a while longer to truly adopt that. But it is an absolute virtual promotion, I like to describe it, for developers, as you get access to far more leverage by being able to marshal the power of these AI agents. And then lastly, the last category or tier that I like to describe from a trust perspective is this notion of superpowers. And this ticks over one last threshold, which is the developer is no longer in the supervisory role. This is the threshold where we believe AI can actually operate based on prior direction, but without supervision, approval, and observation. And I think that becomes the last layer of trust that will take a while for the industry to get to. But I think we would all largely agree that there's some point in time, whether it's a year or 10 years away, will be highly debated, that we'll get to where AI will be able to operate from a data engineering perspective, even without supervision. And that will become one of the really interesting ones to see, can we get developers to actually coach, mentor, train, advise, guide AI in such a way that it can still operate independently when something goes bump in the middle of the night so that the developer cannot get paged at 3 a.m. and have to fix something, but instead can lean on AI to employ runbooks to try and fix the system itself and act as an on-call agent, for example. Great. So having gone through organizational, data access and trust, and now user trust, let's actually go to a third framework here. The third framework is around capabilities, the actual building blocks of generative AI systems. And how do we actually think about this in a systematic way so that we don't try and boil the ocean and create this magical thing that's perfect, that's going to solve all of our pains from the very beginning, but instead think of, where do I start? And if I'm trying to build an AI product, where do I start and how do I build on top of each foundational layer to get more and more advanced capabilities? And so let's actually talk through a little bit on where we start. And at Ascend, the way we focused first was just purely on the core. Metadata model, conversational chats, documentation, lots of example code. We actually work off of that first at our core because those become the core capabilities around really what agents do that then can be orchestrated as part of a larger agent architecture that can solve increasingly complex things. But from a pure product perspective, we just started there. The next layer in the framework really became access to code. And this is the next threshold that we found to be really compelling and also aligns with both the user trust and the organizational data access model, which is if we can give our AI agents access to code, not even access to the data itself yet, we can start to achieve some really interesting outcomes. We can get smart code analysis. We can get it to document and search across the coding content for us. We can actually even get it to start to build things for us in really interesting ways. And I'll show everybody an example of that at the end. The next layer on top of that becomes the metadata. Once we can start to get access to metadata, the system can then do really interesting things, analyze that, and start to think of performance optimizations. AI agents with access to performance data and strong documentation and direction around how to perform optimizations and what optimizations are available on a platform can do some really remarkable things. Similarly, are also open up the ability to do things like anomaly detection, metadata search, really neat things like, hey, can you tell me all data pipelines that have been running for the last month whose resource consumption has spiked recently? As a data ops person, I would love to be able to answer those questions. On most observability platforms, they either have to have thought of that specific use case to give me a report on it, or I just am not going to be able to see it without a lot of manual effort. And then lastly, when we think about the last set of capabilities around data itself, once we can expose data to our AI systems, we get to do some really neat things from a pure data engineering perspective. For example, we can actually have our AI agents do things like analyze the code and then analyze the data and determine should we be running specific data quality checks based on the nature of the data itself and the code to guarantee that the assumptions I'm making in my code continue to be reinforced within the data itself. We can also do really neat things like advanced performance optimization, things that I, as a data engineer way back in my career, used to have to worry about around late arriving data and optimal partitioning structures, all of a sudden become prime candidates for AI agents if I can understand what the nature of late arriving data looks like, how fast my data is coming in, what the distribution looks like across partitions. I can start to actually create Gen AI agents that do really interesting things that will fully optimize my data pipelines without me having to actually get dragged back in the weeds and do a lot of heavy data analysis and performance tuning and experimentation. And so you see, as we start to move up this level or up these tiers, each of these building blocks not only builds on top of the previous ones, but as we give access to additional kinds of data in the system itself, we can do increasingly complex things that give our teams greater leverage. All right. So this all probably sounds pretty neat and cool, but it also probably sounds pretty hard on where to get started. One of the things that I wanted to help share was the fourth framework we think about, which is really much more of an execution framework and really hey, as we go out and build these capabilities into the Ascend product, how have we thought about the approach and how have we been able to achieve different outcomes based on generations of our own AI architecture? And hopefully this will be helpful to everybody else as well. And so first layer that we generally think about this is really just core tools. And the way Ascend builds is actually on what's described as an agentic model. And so at the lowest level here, we don't even think about AI yet. We just think about what are the things that an AI agent needs to do. And oftentimes it helps to not even say, it's not an AI agent. What are the things that data engineer needs to do or an analytics engineer needs to do? And we start to break it down pretty small. For example, it needs access to code. It needs to be able to check code out. It needs to be able to save files. It needs to be able to edit files. It needs to be able to see who modified this file last. It needs to get access to certain data to see when was the last time this data pipeline was run, for example. On top of those raw resources, we give it tools to access those raw resources. So searching, querying, performing Git operations, delegation, which I'll explain in a second. But on top of that raw resource, those tools that we can take actions on become a really powerful next building block. Now, the third piece that pulls this together, and these three really combined are the backbone of what's been branded as the agentic model, which is a very agent-centric model for how we build a lot of the AI capabilities going forward. We create task-specific agents. Think of them in many ways as a junior data engineer that perform different kinds of capabilities. For example, agents that are good at building or agents that are good at testing. And you'll see from our demo, We actually even have sub-agents, and some agents are fine-grained enough where their sole responsibility is just to focus on YAML generation, and another agent that focuses just on SQL generation, another agent that focuses just on Python. Oftentimes, as you'll find, the difference between an analytics engineer versus a data engineer versus an infrastructure engineer will all have centers of gravity, and actually giving each one of them the ability to flex their specialty becomes really powerful. And then lastly, how we pull a lot of this together is with supervising agents that have a greater understanding of the sub-agents, the task-specific agents that are available to them, and can delegate workload accordingly. And it's those supervising agents that can tap into the other agents for their specific expertise that collectively provide some pretty compelling experiences. All right, so now pulling all of this together and showing you how we've done this inside of the Ascend platform, I think I have time for a very brief demo too. First, at a really high level, what we did was we took the core capabilities from a modern data engineering platform. We find that more often than not, most companies in the space and most teams in the space, we spend a lot of time talking about the verbs of data engineering: ingesting, transform, activating, orchestrating, optimizing. But one of the things that we found was all of these systems, when we heavily automate them, generate a tremendous amount of metadata. And this combination of metadata, automation, and AI is one of the perfect sets of capabilities and data you could possibly imagine. Because automation requires so much metadata to do what it does, but also generate so much metadata, that is sheer fuel for the AI engines themselves to do smarter and smarter things. And so as part of the Ascend core architecture, we built this unified metadata backbone. So everything that happens inside of the system generates metadata that feeds not only our automation, but our AI. And that itself opens up this whole suite of new capabilities that we're able to do as part of this unified architecture. Now, a lot of that obviously is easy to say and put into a really cool diagram, but one of the things that I do want to do is I'll actually show everybody what that looks like in the Ascend platform itself, give a really quick demo of how that works, and then I'll open it up for questions and we can answer any questions that folks may have before we wrap up. So with that, let me flip over here and I will show everybody a current demo inside of the Ascend platform itself. So looking here at the Ascend platform, this is one of the new versions of our product. This is the AI-powered product itself. We have our integrated Auto. Auto is context aware, so he knows who I am, also knows what I'm looking at. So for example, if I go over here and open up some code here, you can see I'm actually looking at code. I can ask Auto questions like, hey, Auto, what am I looking at? Give me a quick summary. I'll try and get him to be a little short because Auto does like to get verbose and very detail-oriented over time. So not only can look at the code and tell us what we're looking at, great. But let's say I actually want to do something like, let's say I want to add some data to this component. I have a bunch of driver information in here. I'm analyzing taxi cab data. But at the same time, I don't know the driver's name. What if we said, hey, great, I'd like to add some data to this component. Can you tell me what data systems I can connect to? And so this is where we'll start to get even more interesting. Because as I mentioned through some of our frameworks before, Auto is great if he just has general knowledge about Ascend, but once we actually start to give Auto access to our systems, that's where it gets really neat. And here I've actually given Auto has actually gone and looked at our files, understands what we have connections to, and understands I can read from S3, MySQL, and Snowflake. Obviously, I could go create new connections to read from other data sources, but let's say I already have the data I want in my MySQL database. Great, can you help me read in driver data from MySQL? And let's say we have access to more of our driver data in the MySQL database. Now you'll see Otto is actually able to do a couple of other things as we work up those frameworks I talked about. So first, Otto not only analyzed our connection, it then decided it needed its special YAML skill set, which from a technical standpoint means it's delegating to a sub agent to perform specific actions. Now, as it goes and builds here, it's already creating the code for the SQL component to read that driver data out of our MySQL database. Yep, we want them to go and create that file for us, which would be great. All right, as we do that, let's see. Let me create a new chat here. And then, oh, yep, so it's already moved on. So let's assume we created that file appropriately. But now Otto has moved on to actually adding that data in, which would be fantastic. Yes, can you add that for me? And now as Otto adds that in, not only understands the context from the previous file, understands the context for this file, can update our file, adds in our driver name, and at the same time, we now have the ability to save this file, recompile it, and deploy that to production. And so this becomes really I'd say the first tiers, that tier 1 and tier 2 of the AI capabilities, where just as we give it access to some of our code, a little bit of our data, and then build into Otto a deeper understanding of how to navigate, the speed with which we can build and create updates to existing data pipelines is really quite powerful. So let me pause with that because I think we have just a few minutes left. And I'd love to open this up to questions and hopefully answer any questions you all have, or either around, we can talk about Otto, but we can also talk about some other core capabilities or the core frameworks itself. People have questions there.
Thanks so much, Sean. I did just launch a poll, so feel free to participate in that. Basically asking which of the 4 frameworks are you most interested in exploring more? We can focus some of our Q&A time on those topics. But this also might inform some future content that we come up with. I know, Sean, you've been exploring this space for almost a full year, probably longer than that. And so if we can expand some of this, I think it would be really great. It seems like we have a pretty strong consensus amongst people who are really interested in exploring framework number 3 around capabilities. I think one question to start us off here is, when you think about the future of AI and data engineering, what is available in these building blocks now? And then what do you see in the next 6, 12 months, or even 2 years out? Where do these kind of fall in line as far as industry trends?
Yeah, so I think it's going to be really interesting as there's what I'd consider to be 3 paths of innovation that are happening today. And the 3 paths would be the core model intelligence itself, the frameworks that layer on top of those core models that help us build these AI products faster. And then the third is the actual AI products that we're building ourselves and the data readiness we have around that. I would contend today that the AI models are actually sufficiently advanced. Barely so. Like it takes a lot of bubblegum baling wire and just sheer force of will to oftentimes bend them to do the things that you want. But I think that it will get much easier. As we see what I consider to be the GPT-5 like category models come out, we all already know it's going to be wildly more intelligent, which I think will help. But in some of these domain specific use cases, I don't think it's going to matter tremendously. I think it'll make it easier and will offload the need. But I think, so that's the first part. The second piece is the frameworks are getting way more advanced. And as the models become more sophisticated, it actually allows us to do different framework investments. For example, chain of reasoning, where we used to have to spell out, hey, take this step. I'm sure we all were in ChatGPT trying to get it to write up articles for us and do these other things. And you would be like, hey, first go do this reasoning thing, and then do this and this, and then actually do the logical last step. That's largely irrelevant now, as it's been baked into the core models. And so now what we're seeing is we're moving more to an agentic model, and increasingly to these agents that are able to not only coordinate amongst each other, but are actually even starting to learn and provide self-reflections and feedback and adapt intelligently on their own. And that's certainly a big area of investment for Ascend, is can we get these agents to continue to get smarter and smarter in safe, governed ways, but allow them to do increasingly complex things and learn from their conversations? So I think that's the second piece, and the frameworks are helping do that better. And then the third, I think, is the data readiness piece. That I think is probably the hardest piece right now, as it's the first two are largely delivered by a handful of companies, less than 10 to 15 that will really move the industry. The data readiness piece of, for whatever your product is, how ready is your data? And do you have access to it in the right ways where it's accessible and embeddable? I think that's where most organizations are struggling with. I think one of the reasons why Ascend has an unfair advantage in our particular part of the market is because we are so automation forward and have been for so long. We already had access to a tremendous amount of data, that opening that up to the AI agents was more straightforward than I think it would be for a lot of other either data engineering platforms that don't collect that data or don't have it as structured, or even in other domains itself, where it was just pretty wildly different from a need to collect and structure that data. So I think that will tend to be the longer pull, because it's more of a verticalized drive that's going to take every company to really invest in their own capabilities.
Yeah, that makes sense. It seems like the underlying models from your perspective are getting better, getting us closer to where we need to be. And now it's up to companies to make sure that their data is ready to feed to those systems so that they can build all of these capabilities. Can you talk a little bit too about maybe some resources? Someone's like, I would love to be able to start at the core. Where do I start?
Yeah, really good question. Where to start? I would read a ton. I spend increasingly large amounts of my time reading from the macro market perspective. There's been some really great podcasts that have come out. Sequoia has a couple really great ones. 20 Minute VC has some really great ones. And understanding from what I would contend is understanding the direction from the CTOs of those handful of companies that are really moving the market, from big companies like Sequoia to startups like LangChain. I think that helping to understand where like Microsoft is going and where OpenAI are going will help you understand those broad directions. I think the second part, honestly, if you come at it from the other direction, it's been a long time since I spent this much time on Reddit, but I read a lot of Reddit posts at this point, because honestly, it's you can understand that, and you can extrapolate a lot from the conversations at the really executive level, but things are moving so fast at the hands-on IC level, that by the time it would actually get synthesized and bubbled up to the next industry trend report, will take it 3 months. And if AI computational capabilities are doubling every 3.4 months right now, which they are, it's just like, this is like light years behind already. And so trying to stay close to all the incredible new frameworks that are coming out. Microsoft is doing amazing stuff around AutoGen, which is a very agentic, like multi-agent coordination and communication model. They just did amazing research around GraphReg. There's amazing new research that just came out around rapid input tokenization at really large size and scale. So these things are changing so fast, it can be overwhelming. But all the smartest people that I know and read and talk to seem to think that it's going to continue at this pace for the next 5 to 10 years. And so my general take has been, look, like we could get super intimidated by this and say, we're just going to wait until it stabilizes. But my contention is it's not going to stabilize, at least in the next 5 years. And it's going to continue to move. So like, if you want to participate in this world, you got to get on the roller coaster and get in it and just start educating yourself.
Absolutely. We are just about out of time, but I think getting some of those resources, Sean, that you mentioned in a follow-up email could be super valuable for folks. So definitely stay tuned for a follow-up email. We'll include the recording and maybe a couple of those things that you mentioned, Sean, just for people who are curious to get started. But thank you so much for joining us today. We really appreciate your time, and we hope you all have a really great day. Thanks again.
Thank you, everybody.